Howdy, y'all. Welcome to our MXET 300 final project. My name is Kylie Johannes,
I'm Christian Cruz.
I'm Jonathan Hay.
And I'm Cade Morrell.
and this is our SCUTTLE WaiterBot. The SCUTTLE WaiterBot is a food delivery robot that works autonomously in a restaurant. It uses LiDAR and computer vision for navigation, helping it follow paths and avoid obstacles. The bot has a force sensor to start and signal its return to the kitchen, and a servo-controlled dome to safely transport and serve food.
For our hardware overview, we have encoders, a force sensor, a LiDAR, and a camera as our inputs that go into a Raspberry Pi and produce the outputs for the wheel motor, servo motor, and for Node-RED. The video on the right is showing the force sensor working and detecting whether an object is on the plate or not. And our second overview is over the servo motor combined with the lid, which is an assembly part comprising of 7 parts that work together with the sensor to detect if there's an object on the plate. And once it arrives at the table, the servo will open at the table, wait for the force sensor to detect there's no object, and then close.
For our software overview, our code essentially starts by importing all of the libraries that we use, as well as defining all the functions that were used in the main part of the code. Um, so how the robot works is that it'll start from the kitchen, it'll follow a predetermined path, and while it's on the path, it'll be checking for obstacles that are in the way. If an obstacle's in the way, then it's going to run around it using the obstacle avoidance function that was defined in our code. But if there's no obstacle in the way, then it's going to follow the predetermined path all the way to the table. Once it gets to the table, it's going to open up the servo, present the sushi, and once the sushi is taken off the plate, the weight sensor will flip on so that way the robot knows to return to the kitchen.
So as you can see here, this is just a video of the robot in action. So Christian starts off by placing the sushi on top of the force sensor, which tells the servo motor to close the lid and start the program for driving to the table. Once we drive to the table, after a couple seconds, it runs into an obstacle. So then it makes a scanning movement across to try to avoid that using the LiDAR. After it scans around, it then continues to go towards that blue paper, which signifies the table. We use the camera to basically look at these colors, and it allows for the robot to get back on track to get to the destination. So as you see here, it's continuing to scan until it catches the blue piece of paper. After that, it then follows, arriving at its destination. Once it arrives, it has a delay where the servo activates and displays the sushi to the server. And then once it's picked up, it is then telling the robot that it may close the servo and go back to the kitchen. So as you can see here, the robot starts to head back to the kitchen, and we use Christian as a moving target to kind of allow for a dynamic block. So Christian stands in front. It then notices that he's there, and while he moves away, the robot then rescans to align and moves forward towards the kitchen. Once again, after scanning, it reads the red paper notifying that it is headed towards the kitchen, and after getting there, it presents the servo lid up to then be refilled and loaded with another piece of sushi.
For the work distribution, I was the mechanical lead. I focused on building the robot's physical structure, including the chassis and servo-controlled dome that holds and reveals the food. I made sure that the robot was stable and could transport food securely.
For my lead. I was the CAD lead. So basically what this means is I was in charge of creating all the 3D models of the robot parts, as well as an overall CAD model of the overall system. I also helped design and install some of the chassis and helped a little bit with the mechanical work to make sure that everything fit together and worked properly.
I was the software lead. So basically, I made the software that controlled the robot's movement and the food deployment, and I helped the robot navigate using the LiDAR, as well as a bit of the camera, but the LiDAR was mainly to avoid the obstacles.
And I was the electrical lead. I was in charge of integrating the LiDAR and the force sensor and the motors. I also handled wiring, power distribution, and making sure everything worked together properly for movement and food delivery. And I also coded and dealt with the servo motor and making sure the lid worked with the system.
And then here's a overview of the project timeline.